Good evening, guys, and I'm back with this e-learning. So today we are going to start with section 9.3, and it is the sum and difference formulas for sine and cosine. This is not that much big of a section as it is. So first, two things that you need to know. We need to know our two triangles. We need to know the 45, 45, 90. And the 30, 60, 90 triangles. So let's do the 45, 45, 90 triangle. This is 45, 45. Here's your 90. And we have the sides of 1, 1, square root of 2 ratio. And let's do the 30, 60, 90. In our 30, 60, 90, we have, be careful where the 30 is at, be careful where the 60 is at. Anytime the side that is next to the 30 will always be the square root of 3. Remember we said in class that the 3 sticks together. This is the 1, 2 square root of 3. Or if you can think about it as square root of 3 being a 1.73, 1 and 2. So 1 is the least. It is across from the lowest angle. Then 60 is the next biggest thing. And 90 is bigger than 30 and 60. So that's why 2 is across from it. From here, we have the sum and difference formulas. So if we want to add two angles, or if you want to take one angle and rewrite it, just in case, like 105, we can write it as 100 plus 5. So let me give you the sine and cosine for adding and subtracting. So first, let's start with the sine of A plus B. Sine of A plus B is sine of the first angle, cosine of the second, plus, now we're going to flip this, so it'll be cosine of the first, sine of the second. And remember, it's sine A times cosine B, and cosine A times sine B. Let's do sine of A minus B. That gives me the same thing. The only difference, you see, a plus is a plus, so a minus should be a minus. So this is sine A cosine B minus cosine A sine B. Now this is if the function is sine, and the sum and difference formula. The ones for cosine are, let's do the sum for cosine, cosine A plus B. Cosine is a little bit different. It starts with cosine of the first times cosine of the second. And since it is a plus, be careful, it's not like sine, plus was plus. In a cosine, the plus is a minus. And now we do sine A, sine B. And the difference for the cosine, cosine A minus B, that equals, again, the minus becomes a plus for the cosine function. So this is cosine A, cosine B, plus sine A, sine B. So now we have the sum and difference formulas for sine and cosine. So, for instance, if we asked you, find the exact value for cosine of 15 degrees. Well, in our triangle, 15 is not one of those nice triangles to find the cosine of. But I know if I deal with the 30s and the 60s and the 45s, if I deal with these triangles, I know that a 45 degree minus a 30 gives me a 15 degree. And since I want cosine, I can rewrite cosine of 15 degrees as cosine of 15 as cosine of 45 degrees minus 30 degrees. So now I have 15 to be the same as the difference of two angles for the cosine. Well, we can figure what that is. So, by our formula, cosine of A minus B is cosine A cosine B, so this becomes cosine of 45 degrees cosine of 30 degrees plus sine A sine B, so this is sine of 45 degrees times the sine of 30 degrees. This is why we needed to know the 30, 60, 90, and the 45, 45, 90. So the cosine of 45 degrees is the square root of 2 over 2 times the cosine of 30 degrees is the square root of 3 over 2 plus the sine of 45 degrees is square root of 2 over 2, and the sine of 30 is 1/2. So now we have to perform this algebra here. So we have the square root of 6 over 4 plus the square root of 2 over 4. Since these two have the same common denominator, we can write this as square root of 6 plus square root of 2 over 4. And again, the question asked us for the exact. So this would have been exact, but if I wanted to approximate this, I can use my calculator and do this in the calculator. I would end up with 0.9659. And we can double check that with our calculator. If we put cosine of 15 degrees, remember you have to be in degree mode here because it's degrees. The cosine of 15 in the calculator is 0.9659. So the trick behind all of this is how can I rewrite whatever angle, if it's either sine or cosine, whatever angle that we want, we need to figure out how can I use the 45, the 30, and the 60 to establish that angle. So next I would like to talk about finding an identity for sine 3 theta in terms of sine and cosine. In terms of sine and cosine. Well, again, in this thing, we are looking for sine of 3 theta. All right, so sine of 3 theta. Well, I need it in sines and cosines. So one way I can do is, how can I end up with sine of 3 theta? Well, we can break that down into sine of 2 theta plus theta, because 2 theta plus theta gives me my 3 theta. And now I have the sum of two angles in the sine. So that gets me, by definition, sine of two things is sine of A, cosine of B, cosine A, sine B. So we have sine 2 theta, cosine theta, plus cosine 2 theta, sine theta. Well, maybe we can simplify further. We know one thing. This is sine 2 theta. We know an identity for sine 2 theta. At the same time, we also know identity for cosine 2 theta. So now we have to go back and think, which identity am I going to use for sine of a double angle? So, and we need it to be in terms of sines and cosines. So the identity that I'm going to choose for sine 2 theta is 2 sine theta cosine theta. 2 sine theta cosine theta times this extra cosine theta right here, plus, now I got cosine 2 theta, and we talked last lecture that we have 3 different ways to rewrite cosine 2 theta, but I also have to multiply it by sine theta and try to make this as easy as I can. Let's try cosine squared minus sine squared. Times sine theta. You might ask, like, why am I doing that? Well, I'm just trying to get something that might work here. And there's no right way. You have to keep on trying. And the reason why I did this cosine squared is because I knew cosine times cosine, I'm going to get a cosine squared. Maybe I'll get lucky that I can add some things down the road. So this is 2 sine theta cosine squared theta, plus we are going to distribute. We're going to take the sine times the cosine, and the sine times sine squared, and we are going to end up with sine theta cosine squared theta, and a negative sine theta times sine squared theta times sine theta is a negative sine cubed theta. Well, I kind of lucked out, because in this example we have 2 sine theta cosine squared theta and an additional sine theta cosine squared theta, which means I can add those two together. So I end up with 2 of these plus 1 more, it gets me 3 sine theta cosine squared theta minus sine cubed theta. As you see, again, this is rewritten in terms of sines and cosines. So basically in this section, the sum and difference formulas, we have to abide by these rules right here. The sine and cosine sum and difference. And we have to kind of work this out such that we have, if I'm looking like for a 15, or if I'm looking for even like if I said sine of 30, we can do 90 minus 60. Or sine of 75, I can do 30 plus 45. And just follow that format. And again, rewriting backwards, knowing what this is, I can break like 3 theta or 5 theta or whatever. We can write it as either the sine or cosine of a sum and or a difference. So that's all there is to this. If you want a little bit more work, you can check page 368, which I will upload as well. Numbers 1 through 12. 17, 20, and 21. If you have any questions, don't forget you can email me, and next time we'll go on to the next lesson in this section. So I'll see you for right now. Good night.